Hi, I'm Kyle Exmacher. I'm doing project 2. I'm going to submit a video. So I chose to do a problem out of chapter 12 in the spirit of Pi Day. It's problem 60, page 634. So we have an oil well off the Gulf Coast is leaking, with the leak spreading oil over the surface as a circle. At any time in t minutes after the beginning of the leak, the radius of the circular oil slick on the surface is equal to the function t squared in feet. And then we will have the area of that oil slick, which will be pi r squared, the area of the circle. So first we're going to interpret what the function a of r to the t, and we'll go ahead and do that. So the two functions we are given in this problem is our radius is equal to t squared times squared, and then we're also given the area, which is r pi r squared. So in order to the first question is to find and interpret a r to the t. So in order to do that, we'll just plug in t squared into our area function, and that'll look like this. We'll have pi t squared squared. Oh, we are off the screen. Okay. I'll rewrite it. A r to the t equals pi t squared squared. Oh my. Okay. So the second part of the question asks us to find and interpret when t equals 100. So in order to do that, we would just plug in 100 to t. And we're given squared times pi, and at that point I just plug that into the calculator, and we're given pi which would equal 314,159,265.359. So that's the first problem I wanted to go over, but I didn't really feel like that used any of the derivative rules, so we'll go ahead and do another problem as well. What is this?
Can you just do a new page?
New page. Good idea. Thank you. So the other problem I wanted to do is out of chapter 12 as well. On page 626, problem 53. And that is, some psychologists contend that the number of facts of a certain type that are remembered after t hours is given by the function 90t over 99t minus 90. And we are asked to find the rate at which the number of facts remembered is changing after the number of hours. So in order to find the rate of change, we will need to find the derivative of that function. So again, our function is given as f of t equals 90t over 99t minus 90. So in order to find the derivative of that function, we'll need to use the quotient rule. In order to do that, we basically split up this function into two separate functions, because it'll look like the derivative of f over t is equal to function of u
Scroll down.
of x over v of x. So the two separate functions, the way that will look is we'll have u will equal u of x equals 90t, and v of x equals 99t minus 90. So we will also need to find the derivative of each of those functions. We can do that here. 90t, that simply equals 90, and the derivative of v, space there, is 99. So we'll plug this into the quotient formula, which is given as u, let's forget, v of x times the derivative of u of x minus derivative of v of x times u of x all over v of x squared. So let's plug that in. V of x (99t minus 90) multiplied by the derivative of u of x, which is 90, minus the derivative of v, which is 99, times the function u of x, which is 90t. All over 99, 99t minus 90 squared. So we calculate this all up. It's exciting stuff. This out of we get negative 8100 over 99 t minus 90 squared. And then the problem asks us to find the rate of change at 1 and 10. So we can simply plug in those numbers into our derivative function to find the rate of change, which for 1, the calculator out 1, we get negative 100, and for derivative function where 10, we get negative 0.01, which gives us our rate of change. And that's it. Thanks for watching. Have a great night.